Just a quick one today. Solving equations using the idea of quadratics, even though the equation originally doesn't look like a quadratic. Something like that, a quartic. But if you notice the powers are going down by a regular amount. So in this case, it's x to the power of 4, x to the power of 2. Similarly, you could have had 6 and 3, or 8 and 4. I suppose one double the other, basically, is what I'm saying. You can turn it into a quadratic. You don't have to substitute the pronumeral. You can think of it just as the pronumeral being x squared if you wish, but you might find it easier to make a different pronumeral. So I've said, okay, I'm going to make m equal x squared. And if that's the case, then x to the power of 4 would become m squared. And there's my new quadratic. M squared minus 4m minus 12 is equal to 0. I can factorise that. M minus 6, m plus 2. So either m is 6 or m is minus 2. That, of course, is not the solution to the problem, because remember, m, I introduced that pronumeral. Let's put the x squared back. So either x squared is 6 or x squared is minus 2, leaving me with x being plus or minus root 6. But, of course, no real solutions over there on the other part. Can't find the square root of negative 2. Well, not in the real number system anyway. But we don't have to worry about that other one. So x is plus or minus root 6, the only real answers for this particular equation. One's an exponential equation, but you'll notice the base in this case, one of the bases is the square of the other base. So we've got 3 to the power of x and 9 to the power of x. So it could have been 2 to the power of x, 4 to the power of x, 5 to the power of x, 25 to the power of x. So we're looking at the base here. The base is the square of the other. So if I let m equal 3 to the power of x, 9 to the power of x will be m squared. Now, if it's not immediately obvious why, I can play with my index laws. There it is. So m squared would be 3 to the power of x squared, which I could then turn into 3 to the power of 2x, which then I can swap the indices around and say, well, that's 3 squared all to the power of x, 9 to the power of x. So there's my quadratic, m squared minus 4m plus 3. Multiply together to give 3, add together to give 1. Add together to give 1? Why did I say add together to give 1? Add together to give minus 4, of course. So we get minus 3 and minus 1. So either m is 3 or m is 1. But m was 3 to the power of x. 3 to the power of something is equal to 3. Gosh, I wonder what that number is. Oh, 1, of course. And 3 to the power of something is 1. Well, x is 0, the other possibility. There we go. So that's the basic idea. We're turning an equation which originally isn't a quadratic equation, but turning it into a quadratic equation so we can go and solve it.